Our presenter is Mohammed Aboullaite. The title of his presentation is Move Fast, Build Things Safely.
Hello, amazing people of Craft Conference. I hope you are having a great time, both personally in person, if you are at a Craft Conference venue, or virtually for the people like me. And thank to the organizers of Craft Conference for putting together such a great conference and enabling us having this hybrid experience that even for the people that couldn't be there, like me, to enjoy the conference and learn from best IT experts and IT enthusiasts in the world. Yeah, moving on. Throughout the next 40 minutes or so, we're gonna see some and we're going to talk about some patterns, frameworks, best practices. From my point of view, this presentation is somehow very opinionated, but feel free to ask your questions and leave your comments either after this presentation or afterwards, and reach me through Twitter, and I will leave my Twitter handle at the end. So we're going to discuss how we can build applications, software applications that are safe, and that's the most important thing that this presentation will be about, but also in a fast way. And we all know that nowadays the demand for speed and innovation is everywhere. Users and clients obviously no longer wants to wait for months, weeks, or even days to get their features, to get the functionalities that they have been asking about for the past couple of years, to get their bugs fixes, to improve the user experience for them, and so on and so forth. So the more fast you are in shipping those things, the more um the more better your engagement, the user engagement is, the more better is user retention is, the more that means a good day for your business, and that also means that you are winning the competition and your competitors are having a great day there, a hard day, and a bigger market share for you. However, the enthusiasm to move at speed sometimes create conflicts, especially when it butts up against security, especially traditional security, and how we think about it in some companies and some enterprises. And the problem here is that security tends to value status quo, and in some cases, especially for developers and ops, the dotted hand to increase velocity can introduce some new and big challenges and eventually risks, such as like inefficient testing, especially from a security perspective, skipped processes, since like we care about shipping our software faster, and then we try to overcome and shortcut the processes in order to get there and completely ignoring security. However, speed alone is not enough. We all know some companies that have been bragging for the past couple of years about how they are moving fast and how they are shipping features and how they are releasing new functionalities each and every day, month, week, whatever. And some of them went ever far and added moving fast as one of their values and one of their mottos. However, moving fast alone will make you hit a roadblock and will slow you down in the medium and long term, since you don't care pretty much about security. Worse enough, once security is broken, the trust of your users and your clients is also broken. And I like to say that security is actually is like air. Once, like if it's there, nobody cares about. Like we're all enjoying security and nobody talks about it. But once it starts mission, what once it starts missing, sorry, you everybody notices it and you start appearing the next day in the news. Since unfortunately, or fortunately, depends on how you see it, security is the thing in the software industry that gets a lot of media coverage. So that's why DevOps is desired. We all want to move at speed of light by shipping things faster, introducing new features, fixing bugs as fast as we can. However, security is still required. We should also keep or make sure that the software and releases we are shipping are as secure as we want them to be. So the DevSecOps movements, and by the way, I hate the name and I don't like it very much, but for the sake of this presentation and for the sake of mutual understanding, we will keep it, but you get the idea. So the DevSecOps movement try to brings everyone together, trying to make sure that everyone has a table in the seat, and that's to enable the developers to do what they do best and enable them and allowing them the freedom to focus on what they do best: fixing bugs, improving the user experience, shipping new functionalities, and shipping new features. And DevSecOps also tries to enable the ops people to uh, release the software faster, to make sure that once the artifact and once there is a release from the developers, the ops can ship it in a reliable and resilient way as fast as it is available. However, and this is the most important part of the DevSecOps movement, it also bring security perspective to the equation and have make sure to the security folks have a seat in the table in order to make sure that those releases are as secure as we want them to be, and as secure as our users want them to be, to have to make sure that our releases are actually secure. Now, we can't there's no system that is 100% secure, that we all should agree on, but there are some best practices that we should apply, and there are some standards that we should comply to in order to make sure that our releases are secure. So you'll probably get it. And for the next of this presentation, you probably already figured it out. I am going to talk about the Formula One. Now, during the pandemic, I was sitting in my apartment and watching a lot of Netflix. You know, the world was collapsing, a lot of things were happening, and you get it this try to have a little bit of your own zone, get out from what's happening, and yeah, free your mind a little bit. And I stumbled upon this, or started watching this Netflix series called Formula One: Drive to Survive. And this is basically a Formula One, or a Netflix documentary slash TV show that tells the behind the scene of the Formula One races in a entertaining slash dramatic slash exciting way. You know, the Netflix way. It's cool. I like it pretty much. And the thing I noticed it is that, or yeah, I knew already, is that the motorsport is a very dangerous sport, and that gets confirmed with this documentary. But what I learned throughout watching this documentary is that even if it's very dangerous, there is a challenge that the Formula One people excels at, which is making the Formula One as safe as it could be while keeping the speed high and up. And this challenge is continuously uh, coming each and every year with each and every race. And while watching this documentary, this actually happened in one of the seasons. So this was Bahrain Grand Prix race in 2020. The driver is Roma from the Haas team, who was driving super fast at 160 miles per hour. That is almost 300 kilometers per hour, and he hit with such a great speed and insane speed the barrier, and the car turned instantly into a fireball. Now, this is by any measure, even for the Formula One people, this is a death sentence. Nobody could survive such big and crucial and cruel incidents. But guess what? The miracle happened. And even if Roma stayed there for around a little bit over 2 minutes, he managed to get out of the car, not only sane and safe, but by himself for a big part of the rescue movement. So he managed to get out of the car into the extreme heat from the fireball by himself on his own feet. And that got me thinking. And that confirmed my hypothesis that even if the Formula One is one of the craziest and dangerous sports in the world, they care too much, or they care much, as not too much, but they care much since it's important. They care very much about the safety of their drivers and the safety of the drivers of the Formula One. And what then would happen if we designed our architecture, if we designed our system with the same level of devotion? Then we would build a systems that enable us to move fast and in a secure way. Now, throughout the episode and throughout the whole seasons, the Formula One people keep using the word safety and little to no mention of the word security. And I am not an English or a native English speaker, so I use them pretty much interchangeably. However, I decided to open the dictionary and look for the definition of safety and security and check if there are any differences. And what I found was really surprising, at least for me. Or uh, I learned a lot. So the security meant that security, or the security meant the state of being free from danger or threat. Now, from a security point of view, or from a software engineering security point of view, this is not what we are trying to achieve, isn't it? I mean, if you think about it, we know that from the moment we put a software to the internet, the application is no longer secure. Our code is no longer secure. There are tens of hundreds or even thousands of things that try to break our system, breach and use the vulnerabilities that we expose and try to steal data of our system and try to break our system and have outages and a lot of stuff. So, from a software engineering point of view, security is not the right word. But safety, on the other hand, means the condition of being protected from or unlikely to cause danger, risk, or injury. And this is exactly what we are trying to achieve with security and software engineering. We are to protect our system from all those malicious users, from those attackers, from getting our data stolen, or keeping our system up and running and not having outages, and keep serving our data. So rest assured, I'm not going to suggest a DevSafe movement, but just to say that uh, good architecture should let us and let everyone move and go as fast as possible in a safe way. Good architecture should enable us to deliver software faster, ship code faster, and introduce new functionalities faster to our users in a safe way, keeping the data of our users safe. Now, I did a couple of research and I found that the Formula One people throughout the years introduced a lot of safety measures, both before the race and before the crash and after the crash. Those are measures and stuff that the Formula One people have a checklist to do, or yeah, introduce it both before the race and after a crash is happening, to make sure to get the driver safe and keep the driver safe, and make sure that the one of the dangerous sports and motorsports in the world is as safe as possible. I picked five, both I picked 10. Five of them are pre crash measures, and five of them are post crash measures. There are obviously more, but throughout this presentation, we will go over them one by one and check if there are any lessons and patterns and best practices that we can get out from the Formula One people. And uh, it's, I mean, those safety measures really help to make the Formula One like as safe as it is nowadays. So if you check this graph, the first one is compares the dates per year, and you can see as more safety measures are introduced, as the less deaths we have. And the latest death accident was happened in 2014, which indicates that it's actually helping to make the Formula One more safe. And the second one is the number of days between fatal accidents. And here again, as you can see, the more safety measures we introduced, the more we're helping to make the Formula One a safe race, a safe motorsport. And this got me thinking that for sure the IT people working with the Formula One engineers should get inspired and should learn how to make software, state of the art software, that are actually safe and secure. And to my big surprise, it actually, no, even the engineers working with the car manufacturers that are helping to make Formula One of the safest motorsport, even if in extreme speed, didn't know how to make the systems or their IT systems more secure. So let's move on and let's go over for the next for the rest of his presentation. Let's go actually about each one of these items and check for any patterns and any lessons that we can learn about how we can make our software more resilient, reliable, and secure / safe. So the first pre-crash measure, so fasten your seat belt. We will start going fast nowadays. So please stay safe, and I hope you can follow up with me. It's going to be a lot of learning and fun. So the first one they have a seat belt. Not a big surprise. Even in our cars we have seat belts, but the important one, or differentiator element about the Formula One seat belts, is they feature 6-point safety harness, and they have multiple levels of security, and they go through rigorous testing procedures to make sure that there are no degradation and they are as safe as they should be. And those seat belts in the Formula One are designed to minimize the risk posed during a race weekend. And the really important one is that the driver can hit one button to get out and to fasten the whole 6 harness. And in a software engineering world, this actually very similar to the release, to the push to deploy or push to release button, right? So you push one button and then the magic happens. Now, I'm going to talk about CI/CD pipeline in a bit, but I want to highlight the importance of having automation in place, because there are a lot of goodness on having automation in place. Things like checking for software vulnerabilities can definitely be handled automatically, and that helps to free up teams to pursue more productive and innovative pursuits. Automation can also help to decrease the number of errors that occur with a manual approach. Whenever there are humans doing especially a repetitive job, then there are definitely errors, and there are possibilities of mistakes to be introduced. So this mistake can lead to software vulnerabilities for sure that can turn sorry that can turn into costly security breaches. So having automation end to end and lowering the human interaction can lead to a more secure and more fast releases. The second pre-crash measure is actually stringent dynamic, static, and load tests to ensure the safety of the drivers. And that means that they make sure that the car is tested in the different environments and different conditions that it's gonna experiment during a race day. If it's raining, they test the car during the rain. If the race is raining, they test the car during a hot day. If it's sunny outside, they test the car if in a windy weather, if to prepare it for the windy condition, and they keep monitoring and testing the car and noticing if there are any improvements, especially from a safety measure and also from a safety perspective, and also from a speed perspective. And what does this means for us in the software engineering world is that is the equivalent of having a trusted, repeatable, and most importantly, adversarial CI/CD pipeline, enabling us to test effectively and repeatedly our changes, our code changes that we introduce it to our application, not only at one point in time, but in any point we introduce a changes. And in any moment we introduce a code change, the application, sorry, go through a stringent process to understand if the application is ready for the actual conditions it's going to face during production. And adversarial is important here since we make sure that we hear everyone's voice, not only developers and operators, but also security. And we are engaging security throughout the development and operations processes to ensure their involvement as we align to the process with that helps to increase adoption of security practices and continuously fixing and testing defects. This is actually devsecops in practice as we want it to be. Another practice we can do to make sure that we are testing and making sure our application is ready for the same conditions it's going to experiment during production is actually canary deployment. And canary deployment is a pattern for rolling out releases to a subset of the users. It could be a small percentage, like 1%, 5%, whatever your user base is and whatever you feel confident about. And the idea here is to first deploy the changes to a small subset of services and users to test if it meets the metrics and it meets the confidence and it meets what we want it to be, both from a functionality point of view to make sure that it's not traditional regressions, and also from a security point of view, that is, we're not deploying a defect artifact. And if there are warning indicators, we basically roll back and we do not continue to deploying and rolling up the application to all users. And if everything is okay, then we continue rolling out the application to all our user base. That will help us to gain confidence over the reliability and resiliency and the security, of course, of our application. Moving on, the third thing, or the third pre-crash measure, is the cockpit is surrounded by deformable crash protection structures. And this is actually how the cockpit look like without the fancy design around it. And they built the car around this piece of structure whose sole purpose in life is to protect the drivers, and they are testing this the cockpit all the time and in different conditions as well. This is actually designing for the worst case. And what does it mean for us in the software engineering industry is that we, and by we I mean everyone, especially developers, should care much about fault tolerance and making sure that our applications have fault tolerance in all layers. No longer developers confine themselves to thinking only about functionality. We must also consider the question of how we provide that functionality in face of outages, in face of database failures, in face of network problems, in face of attacks, in face of a lot of there are a lot of things that can go wrong when we deploy our application, and designing for failures and having fault tolerance and making our applications fault tolerant is really important. Another thing we can do to make sure that our application is actually more resilient from a safety point of view is making sure that the data flow that is secure, that is circulating inside our cluster, is actually encrypted and secure. And for that, we can enable things such as mutual MTLS, mutual TLS, sorry, like mutual transport security layer. And mutual TLS basically define the secured communication when both parties, when both identities are verified. So it's like TLS, but with both parties, both the client and the service agrees on something, and each one identifies and verifies the other before starting communication. So when mutual TLS is used, both identities are validated, and the data payload that is circulating inside your cluster is encrypted, which is a great win from a security point of view. Another thing we can do to ensure the resiliency and security of our application is designing our application in a micro-segmented way. And this is a great thing to think about when designing our application, since microsegmentation guarantee that sensitive data are never exposed to the system or to the internet, sorry, uh, and they are far away, or the data and the services are in the data are far away from the internet as possible. So even if an attacker manages to get access to one of the services, they will only have access to the internet facing services and not the data. Uh, and this is a great from a security point of view, since they will have to do additional work and additional smart work to do in order to get inside other layers and other reach the data owning services. So as with the cockpit that is deforms itself in order to protect the driver, our application that is designed in a micro-segmented way will deform itself in order to protect what we the most precious thing we have, which is the our users data. The 4 pre-crash measures is actually before the race, driver must demonstrate they can get out of the car within 5 seconds. This is not only designed for the worst case, but this is actually testing for the worst case. Testing the ability of the driver, if a crash happened, he can get out of the car during that day under 5 seconds. If he cannot, goodbye. I mean, if he cannot get out of the car under 5 seconds, he will basically not be able to like race for the day. And from a software engineering point of view, this is similar to start adopting chaos engineering. And a chaos engineering is basically a discipline to identifying failures before they become outages. And they will help us to uncover and reduce the unknown unknowns that make outages more more big. There are things that we know about our applications, and there are things that we know that we don't know about our application. But what scares me the most is the things that we don't know about our application. And adopting and start doing chaos engineering would help to discover those unknown unknowns and start to put in fix and procedures to fix them. And it's like actually a brain training, and you are strengthening your brain muscles and train it for in case of outages how it should react, and also helping you gaining confidence and understanding of your system and how it will react in case of outages, obviously. And adopting chaos engineering is not actually you can start small. It's not actually about going only big. You can start in by designing the smallest possible experiment to test your system. You can start by introducing a small delay on your system and see how in one endpoint and see how your system will basically react, and note the lessons, how your system react, and then start with deploying some fixes. And then once you gain confidence over this test, then you can grow the test gradually. You can now start returning errors, 400s, 500s, and see how your system reacts, and repeat the process and grow gradually until you gain more confidence, and you can now start doing crazy things like shutting down databases, randomly shutting regions and ancestors and clusters. This is all comes with a gradual work and repeated process. And the final one in the pre-crash measure is a constant monitoring and replacement of the tires. And I invite you to watch this video and look how the Red Bull people or the Red Bull pit crew are proud and happy for not fixing the tire, but for changing them in less than 2 seconds. To be more precise, in 1 second, 82 milliseconds. Why the hell in the software engineering industry we are so proud about keeping our systems up and running for years? Some of us brag that our server has been running for 5 or 3 or 1 year without being rebooted and patched and fixed. What would happen if we start adopting the same attitude and the same pattern and the same culture as the pit crew in the Formula One race? What would happen if we start adopting the chickens analogy? Now, we all know, or some of us at least know, that the pits versus cattle analogy, which basically says that we should not have this personal relationship with our infrastructure. It's basically on-premise versus VMs with the rise of cloud. So pits are actually our service, our on-premise service. Since we keep fixing them, we give them names, we start to nurture them, and then we're having this kind of personal relationship with them. And the cattle are basically VMs that we start them at well, and then stop them at well. And we don't spend too much thinking about them, and we're treating them like cattle basically. But what will happen if we push this zoomorphic analogy, sorry, that was hard, zoomorphic analogy a little bit further and start adopting the chickens analogy? The chickens grow in maturity much faster than cattle's. 6 weeks for chickens compared to 24 months for cattle, and they are more efficient than cattle for resources consumptions. The amount of resources the chicken consumes in order to reach maturity is much more lesser than the cattle. Adopting this analogy which actually uncovers new metrics that we should care about, like the reverse uptime and base image freshness. Now, to understand the reverse uptime and why it's important, let's consider an example. Imagine that you have configured a production cluster, and in this cluster, you are running a mission critical application, and a hacker managed to get access and sneak in to this application. Now, this is bad by itself, but what is even worse is that an attacker managed to hide its presence and then use this node as a base to start attacking other nodes and getting root access to whole your cluster. But what happens if our nodes are constantly replaced? We just kill each node after a certain uptime let's say 1 day, let's say 1 week, depends on your need. So once the node is out of the cluster, it is replayed, it is scaled, it is turned down and replaced by a freshly new started provisioned node. The hacker has lost their base and the problem has been eliminated, at least temporarily, since he needs to do the same process all over again. So, from a security point of view, you can't backdoor a system that is constantly being revised. Reverse uptimes then helps us to track the security of my system and uh, build alignment between security teams and operation teams in terms of not only security but also from a stability and resiliency of my distributed systems. So this is why reverse uptime is really an important method to keep about both from a stability and a security point of view. Now combine this with the base image freshness, with the base image of that is shared between multiple clusters and multiple applications and multiple nodes. So even if there is a zero-day vulnerability and I managed to fix it, me as a security engineer, I know that the maximum amount of time my system is exposed is basically the reverse uptime. And then after that, the base image freshness that contains the fix of the vulnerability, even if it's big, like 0-day vulnerability, will be deployed across the whole cluster. And the smallest the reverse uptime is, the better from a security point of view. And I mean, this metric depends obviously on a lot of metrics, and it's context specific depending on your needs. Moving on. Now we finished with the pre-crash measures, and we're going to the post-crash measures when the accident has happened and the car is actually burning. The first thing they have or they do is the driver can be extricated from the car by lifting out the entire seat. They designed the car in a modular way, enable them in case of a crash, in case of an accident, they can lift out the seat and the driver out from the crash scene and give him in another place whatever treatment he may need. And from a software engineering point of view, this is similar to designing our application in a modular way, enabling us to pull out the trigger whenever something is happening. Think how fast you can invalidate a certificate that it has been leaked to the internet. Think how fast you can invalidate an SSH key that some developer pushed to a public repository. Think how fast you can invalidate a secret that has been leaked. Designing our system in a modular and loosely coupled way help us to keep the data safe and lift whatever and put whatever measure is necessary to ensure the safety of our data and pull the trigger on the damaged environment. And the most coupled your system is, the more complex it is, the more slow you are to intervene and react if something is happening, just like the car analogy. The second thing they have is they have a hands system, and hands stand for hand and neck system, that absorbs and redistributes forces that would otherwise hit the driver's skull and neck muscles. This is how actually a hand system looks like, and it's basically absorbs the forces that are generated by the crash and then redistributes them through the driver's body that would otherwise hit his neck and skull muscles. And from a software engineering point of view, this means that we should design our architecture in an elastic way. If you're having a good day and an article or a blog post in Hacker News is like adding or sending too much traffic to your application, you should have load balancers that basically try to absorb the traffic and redistribute the traffic throughout your whole nodes equally and evenly. If the load is too much and your available nodes cannot handle the load, you should have autoscaling in place that automatically spin up other resources and other nodes in order to handle the load. If some services starting to behave badly and start to take more time to respond, you should have request time threshold in order to forgot about the request, remit, free up the resources under thread in order to handle more urgent requests and more users. In some cases, having a degrading performance is a lot more better than having no response at all. And also, adopting and having on-time overload patterns in our applications, such as the circuit breaking and exponential backoff, helps to help our system to make our system more resilient in case of something happen and our system is behaving weird. The third thing they have is drivers were fire resistant suits that would stand fire and help the driver's body and keep the driver's body under 41 degrees Celsius at least for 11 seconds. And this is actually what helped our friend Roma to stay alive and even in the extreme heat for a little bit over 2 minutes. And we should adopt some patterns to help us contain the damage of the attacker. Things like least privilege, where we make sure to give the application and the service the minimum set of access rights of resources, enable it to perform its function. Having defense in depth, where while building layers, making it hard for the attacker to escape and do more damage. And having a zero trust policy, and that eliminates implicit trust and continuously validates every stage of interaction, helps to contain the attacker in case of a security breach. And also adopting hardware security modules. And to understand it, let's actually take an example. Imagine an attacker accesses and exfiltrates the contents of some database. Now you are hashing the password of the database with some like function, and then the attacker like took the data and put it out from your cluster, and then he brute forces until he managed to reverse engineer your hash function and have the password of your users, and you don't know about it until you see it the next day in the news or in the black market. However, let's take the same example, but instead of simply hashing the password, we first apply an operation using key generated inside our hardware security module. Adding this extra step makes the data actually useless outside our cluster. So we are keeping the attacker inside our cluster until we are hopefully aware of his presence and we take whatever measure necessary to get him out. The fourth thing they have is a fire suppression system that can be activated by the driver externally or by the race marshal. And this is how the fire system works. And keep note of the levels of access they give. If the driver is there and is conscious, he can activate it by himself. If the rescue team is there and the driver passes it out, they can activate it. If the driver passes it out and the car is burning and the safety team cannot get in place, then a race marshal can activate it externally. And from a software engineering point of view, it's important to have access and communication policies in place, making sure that you give access to only the people that needs it, not being too tolerant of giving access, and also not locking yourself out of the door. Having security, having policies and things like airbag and ASIL and communication policies are really important to get right. And finally, they have data records that keep speed and deceleration forces, so doctor knew the severity of an impact. So before, once a crash is happening, the doctors already have the data and know how bad the crash is, and they know whatever treatment they should give to the driver in order to save his life. And needless to stress here and needless to emphasize the importance of monitoring and having monitoring and alerting tools in place. No system should go in production without monitoring and alerting tools in place to detect unusual behavior and trigger alerts. And finally, look at this picture. And this is just to say that drivers of the Formula One manages to um, achieve speed, manage to achieve safety, but they are not comfortable in the way they drive the car. And this is the trade-off we need to keep in mind. Security is about trade-off. So there's a trade-off that you're gonna do between comfort and security that you will probably need to some questions that you probably need to answer while designing your system. And I'm gonna end this presentation with some scary numbers from cost of data breach report by IBM Security. So they said in 2021, the average business cost of a cybersecurity attack is more than 4 millions. But this is what scares me the most. It takes over 287 days to detect data breach. This is a lot of time. It means that some of us will have an attacker sneaking in hidden that is stealing our data and we don't know about it. So I hope that throughout this presentation, we learned some patterns, some frameworks, and some practices that will help us to move fast while keeping our system safe. Mohammed was with you. If you have any question, I'm happy to answer them. Otherwise, please shout to me in Twitter. My Twitter handle is Laydoun. And those are some resources that helped me to build those materials. And I wish you a great conference, and I am ready to take your questions. Thank you.
Wow, thank you, Mohammed. I love the analogy between Formula One and security and the way you put this whole presentation together. That was outstanding. I gained some more, as a non-technical person, I gained more insight into security. And I do realize from looking at it from the outside, how important security is, especially in this modern day. And you really broke it down and explained it comprehensively, beautifully. Thank you very much.
Super happy to hear that. And super looking forward that the attendees had the same experience. And if there are any feedback questions, happy to hear either now or afterwards.
Okay, I'm going to have to ask you to take these questions afterwards because we ran over time and we're cutting into people's lunch times now. And, you know, lunch is an important event in the day.
Absolutely.
So I'm going to tell all our viewers that if you have any questions, you can put them on Hopin or Slido, however you want, and Mohammed will be able and willing to answer any questions that you have.
Definitely.
Thank you again, Mohammed. Wonderful presentation. Enjoy the rest of your day and have a nice weekend.
You too. Thank you. Cheers, everyone.